Okay, so we're problem 2.26 here. And in this problem, you're given an expression for the position as a function of time. Okay, so I've done a little bit of pre-work, although not very much, to get this thing ready for us. So what I've actually done with this, so you'll see over here I have some times and some positions here. So what I've actually done is I just plugged an equation into Excel that matches the one in the book, and I just had Excel do the work for me. Okay, and then the other thing that I did is I just went ahead and I plotted it out because I wanted to make sure that it was pretty good. I even messed it up a little bit right there, but in any event, and a couple things become evident. I'm gonna just sort of draw our smooth curve here to interpolate between the points, not screwing it up too bad. Okay, but the first thing that we see here is that, well, it looks like a parabola to me, and it looks like at time is equal to 2, the position is minus 2. It looks like that's the bottom of the parabola. Okay, so we're asked to do a couple things here. Determine the particle's velocity. So in part B, we're going to do it by actually looking at the slope. And so what I'm going to do is sort of take my trusty ruler here, and I'm just going to kind of eyeball this thing. And I'm not going to try to be too perfect, but I'm going to put that slope on there. And I don't know if you can see that very well, but so when I do this, what I'm looking at is right around that point. What's the rise over the run? And I put it on graph paper because then it's pretty easy. And I can see that I'll pick a couple of convenient points. I'll pick that point. I'll do a different color. Try to do green. Well, that didn't come out very well. That point and maybe that point right here. And on this grid paper, I go down 1 unit. And on my grid, that's over 0.5 units. And of course, it's negative. So my slope is going to be minus 1 over 0.5, which is 2. And the units are meters per second, of course, negative. Okay, so that is my instantaneous velocity at 1 second. All right. And then we're asked to determine the particle's velocity at the same time by taking the derivative. And so here's where we sort of have to use the expression. So let me write in the expression. I'm going to take the derivative of the position, which we're told is minus 4t plus 2. This is in meters. I'm going to plug everything in right. So derivative of the sum is the sum of the derivatives, d dt of t squared minus, bring the minus and the 4 outside because those are constants, d dt of t plus d dt of 2. Well, derivative of a constant, 0. And then I have to work through each term here. So I bring the 2 down, 2t minus 4, and the derivative of t to the first is just t. Is just 1. And then the derivative, of course, of the constant is 0. So this is my expression for the velocity as a function of time. And so when I plug in the expression Vx of 1 second, I get 2 minus 4, which is minus 2 meters per second, which is what I found before. Good. So that looks pretty good. We're going to go on to the next page here. Actually, no, I'm going to wait because part D asks us for any turning points. And the turning point is when the velocity changes sign. I think when we look at the graph here, point right here, that's going to be our turning point. So we have a turning point where v of x changes sign at t is equal to 2 seconds. So that makes sense to me, I think. Okay. All right. So I'm going to go to the next page here, and we're asked then, where's the particle when Vx is equal to 4 meters per second? So E here is where is the particle when Vx is equal to 4. Now we can look at our graph and we can basically, we do this two ways. One, we can try to use our ruler to look on the graph, and that's a perfectly reasonable thing to do. I think it's a little tricky here, but we're looking for when that's the case, okay? We don't know the position when the velocity is this. So here's one technique that I kind of like. We know, we have from the other page, we know that Vx is 2t minus 4. And so we can use algebra. We can find the time for which that is 4. So I bring the 4 to the other side and I get 2t is equal to 8, or t is equal to 4 seconds. In other words, at 4 seconds, that's when my velocity is 4 meters per second. All right. And so if I look at my plot that I have on the other page, I'm going to bring that over real quick. I'm looking for the position at 4 seconds, and I have a point. I have a point there, and it's 2 meters per second. So the position at 4 seconds is 2 meters. I'm sorry, 2 meters. That's right. Good. Okay. And the last thing that we're going to do is draw a motion diagram for the particle. And it's going to look something like the following. All right. So this is going to be a smidgen tricky because the particle actually it goes to the left first and then it goes back. So what I'm going to do is I'm going to call this my starting position. So this is x is equal to 2 meters, and I'm going to draw. So I'm going to put my scale in here. Let's say I'm going to do. So I'll do it in let's say I want to do it in maybe half meter increments or so. That'll be pretty good. So that'll be 2. That'll be 1. That'll be 0. That'll be -1. That'll be -2. This will be 1, 2, 3, 4, 5, 6, 7, because I know it goes all the way out there. And basically what I'm going to do is I'm going to draw the motion diagram based off of the spreadsheet or the set of values that I found before. So at time increments, so my delta t is going to be 0.5 seconds. Okay, and I'm just basically going to read it off. All right, so at t is equal to 0, I'm here. Okay. And then, so this will be 0. That's a good point to have on there. So that's x is equal to 0. So I go to 0.25, which is 1, so it's going to be something like this. And then I go to -1, which is right here. And then I go to -1.75, which is here. And then I go to -2, which is here. And we can see that the spacings are getting closer. Okay. And then what I'm going to do now, just for clarity, I'm going to do the rest of it just below, just so that we can see that. So the next time I'm right here. And then the next time I'm at -1. And then I'm at, this is wrong, this should be, I'm sorry, I got the wrong, I'm going to change this right now. This is plus 0.25, and I know that. So then I go up to here. And then the next time we are at 2, so that's 1, 2, so we're back where we started. And then the time after that, we're at 4.25, so 2, 3, 4.25, we're at here. Notice that the separation between the dots is getting larger. And then finally, at 5 seconds, I'm way out here. Okay? So try to follow kind of in this manner, and then in that manner, that dot diagram.